Right, hello Paul, hello Andrea. You would have noticed that these paper fives were marked this morning, and I just have a few comments that you need to look out for. So I'm not going to go question by question, just a few hints and tips as you prepare for your paper fives as well. It is essential that you read the information carefully. This is a practical application paper, so they will give you most of the information that you need within the question, and then you have to fill the gaps with obviously what you have. So for instance, you're dealing with an acidic gas here, you're sending it through, or you have two methods, A and B, that you're going to use. The one is using measuring cylinder, other one is using gas syringe. Immediately you need to think, okay, the gas syringe has smaller increments in the intervals, so it should be more accurate or more precise for that matter. Second thing is, this is just the gas being given off and pushing my gas syringe out, and so we can measure gas being released. With my first method in A, the gas is being bubbled through water, so there could be a potential reaction with the water. And this is also what they ask, so going through this, you need to be very specific on how you answer. You can't just say, well, there might be something in the tube, or there might be another gas in there. What other gas would be? Well, there will be air in there. So that's why we don't take the first sample in there, because there's air in this delivery tube. There's air in that delivery tube pushing out, first of all, a downwards displacement of water, or the pushing out the syringe. So think about that, for instance. Two other reasons why method A would not be a good method. Well, we said that there's water, so that gas might react with water if it's acidic, and we know this might be nitrite gas going off, so it's and forming nitric acid. So yes, it's most probably going to dissolve in the water or react with the water, making the gas volume less at the top there. And the second thing is, as this reaction becomes less and less and less, some of the water can be sucked back into this delivery tube, because what's happening in here, my heat, or when I remove my heat, for instance, as well, that's one thing, either removing the heat or the reaction stops, this temperature drops and the pressure decreases, so it's going to suck back some water into that. It happens very often, even in normal school experiments, that's going to happen. So something to look out for in an experiment like that. Okay, so now they say you've got that gas and you passing it through soda lime, and they're telling you what is soda lime. Well, it's a mixture of sodium hydroxide and calcium hydroxide, so something alkaline, because this gas is acidic. Right? So immediately, acidic gas, alkaline substance, there's going to be a neutralization or neutralization reaction. So there's going to be a reaction that takes place, right? State the measurements needed to determine the mass of gas absorbed. So it's important to state we must measure the mass of this U-tube with the soda lime before, as well as the mass of that U-tube and soda lime after, because only by subtracting those two we'll get to the mass of gas that was absorbed. Okay, we talked about the alkaline and acidity. Now, whenever we work with a dangerous gas, now our lab does not have this in, and this is also why most of these experiments are not required to be done, and why it's not a physical practical. So if something causes respiratory distress, a mask is not going to be suitable. You'll need to do it in something called a fume cupboard. So an extractor fan connected to a closed container, obviously see-through walls and whatever, and it sucks out whatever gas is being produced in there. So that's a fume cupboard. So remember the terminology fume cupboard in there. Okay, calculations, you guys were spot on. Please remember you're going to get calculations like these, relatively easy to do. Be careful, watch out. So look at the significant figures in there, so anything between 2 and 3, because there were 3 in my R value and 2, so anything 2 or 3 would be accepted in this answer. Be careful. Then they're going to obviously ask things about ratios, and you both answered it really well. There's no problem with your understanding on that. It's good. Same for this sub-question number 4. They say your molar mass is going to be greater. Now, if I look at my relationship of molar mass, it's inversely proportional to my mole. So if my molar mass is greater and being calculated, it means my number of moles should be smaller. Secondly, if I look at my PT ratio to N, if my mole is then going to be smaller, my P over T ratio is going to be lower. And it could be caused by either a lower pressure or higher temperature. And they didn't ask this encircled part. It could be a potential follow-up question. So again, have a look at that. Reliability. Now, the norm is that we repeat an experiment 3 times and then calculate an average. So you cannot just say repeat the experiment how many times. So it needs to be specific. Repeat at least 3 times and then calculate an average. So you'd see you'd not score the mark if you didn't mention 3 times. Okay? They're changing the experiment. Now they're changing the acidic gas with an alkaline gas. So we need to also replace the soda lime, which is alkaline, with something that's acidic, because we would still like that neutralization reaction taking place, a reaction taking place, and we can measure whatever is released. So very basic question number 1, usually with the methods in there, with calculations, conclusion in there. Experiment 2, let's talk about that one. Right, so they did something almost similar, not similar, but they also, you would see the chemistry experiments stays relatively similar also to what you did in AS practicals. You need to think about how to practically do this, and we did this in AS practicals where, for instance, where you have your crucible, or where you have a certain a test tube with a mass of something in, and you want to determine the mass of that. So you must have the mass of X plus the tube, and then the tube separately, and subtract the 2 to get the mass of the substance. So always think about that concept when you're reading through a method. And this is exactly what they wanted you to do. And again, being specific, you can't just say determining the mass of the reaction tube. Well, they're saying you have the mass of that reaction tube with a quantity of iron wire. You want that reaction tube empty. If you have those 2 values, you can calculate the mass of the iron wire. Also, the way the sidearm conical flask before the time, the empty one before the time, because you have at the end the sidearm conical flask with the iron chloride in. So if you have the empty one in plus the weight or the mass of the flask plus the iron chloride of iron, you can subtract the 2 and you have the mass of the substance. Interesting, a precaution. So if you heat it before you allow the chlorine gas through, you might get rust forming, iron oxide. This is a very high possibility that something like that could happen. So you need to replace the air in there, the oxygen, with chlorine, and that's why the flow is through there. So Again, thinking clearly when you do this paper 5. It is really based on, can you think what might happen? State an assumption that is made in this, well, all the iron reacted. That's an assumption. Or that all the residue in the reaction tube is iron. So, because they don't tell us that, we're assuming that within the reaction. Be careful with the calculations. Read your question very carefully. Decimal places, significant figures, and be consistent within a column. If you're working to 3 significant figures, keep to 3 significant figures. If you're working to 2 decimal places, keep working to 2 decimal places, for instance, throughout the column. So that's a little hint. That should score you a relatively easy 3 marks. Again, graph, relatively easy because they give you the labels. You just need to go and pick the points off. All right? There's nothing difficult about it. Just remember, if this is, for instance, my point, I shouldn't touch the sides and I use a cross to mark it. So that's a little hint and tip for that. They ask you encircle the point on a graph that you consider to be anomalous, so then you do it, and you do it with pen. That's fine. That's my anomalous point. So it doesn't fit into my line of best fit. It would throw off my whole line of best fit. For instance, my line of best fit isn't very nicely drawn because those 2 points at top is not really in line. It's difficult on OneNote. That's my reason. Please use a clear ruler when you do the graphs and physics POR as well, and then with the chemistry, so that you can clearly see through the ruler your points and you can adjust your ruler. Okay, why would it be anomalous point? Well, the amount of chlorine is lower than expected. Atoms in there is lower than expected. This could be because some of my iron chloride escaped with the excess chlorine gas out of the tube. Okay. When we do gradient, this question is always in there. So your question 2 in the paper 5 has got a graph in. You have got a gradient calculation and you've got a table in there. So there's at least 5 marks that is very easy to score. And remember, this is coordinates, so that's x, y, and POR, x, y, and your gradient delta y over delta x. Important, again, your gradient, the part of the graph that you're using, indicate on the graph, so it's easy to get the coordinates, and it must be more than half the line. This is NB. If it's not, if you just took a little spot like that, you won't get the marks, any marks for that gradient calculation. It's 2 marks that you're throwing away, so please remember that. And then you get your gradient. Then how could we use that to calculate the formula? Well, we use mole ratio, and I'll show you in the on the next page. Remember how to do mole ratio for empirical formula again. Just going, there we go. So for F, this is how we can use mole ratios. If we have a certain amount of mass of iron, and if it's percentage, we can say this is 44 grams of 100 grams sample, for instance. This is how I can use it as mass. Determining my mole, dividing it by the smallest mole, I get a mole ratio. If it's a whole number ratio, that is my empirical formula. Okay, so this is what this question also alluded to. So how you're going to use the amount of mole of chlorine and iron? Well, we're going to do mole ratios. Uncertainty, very important. If we have a balance, and it's specifically with a digital balance, If it's to 2 decimal places, it's usually the last one that we're going to use in digital apparatus as my uncertainty. If it was just a normal measuring something like a ruler, and there is a first reading and a second reading in there, it would be half the smallest increment. So you would see in the marking scheme, they make allowance and say zip that. So twice times half the smallest increment, because this is my smallest interval in there. Right? My smallest interval, this is half the smallest one, but because there's 2 readings that you take in there, the first and the last one, we can use this. So that's how I get my percentage uncertainty. Again, important significant figures, keep to your significant figures. And then, again, use your brilliant brain to think about what happens if the mass difference is greater, for instance, or smaller. What's going to happen to my percentage error? Again, you guys got it. There's nothing wrong with it. The last question was a very interesting question, and it's a bowl over question. This is the one that separates the A+ candidates from the A candidates, and I know you guys can do this. So what are we looking at? We're looking at my redox table, and remember that potential, electrode potential is given for the reaction in that direction. We have a method in A, and we have a method in F. And the method in F...
Moet hier nog steeds 1 uur en 15 minuten wees? Want het is wel snel. Is het alright?
Ja, geef hulle daai extra tyd. So what happened in F? In F, this was the chloride that formed. In A, this was the chloride that formed. It said, explain using the electrode potentials in the table why the methods in A and F do not produce the same chlorides. Okay, so why would they not produce the same chlorides? We need to think about my electrode potential. In F, this is the reaction that we're looking at actually. My iron, in reacting with my hydrogen chloride, is actually going to an iron +2. This is a viable reaction, it's spontaneous. This is why it's more likely to form. It's not going to continue to a iron +3 if it's going from +2 to +3, because in this direction it is giving me a negative electrode potential, which means it doesn't go spontaneous. So this is why there are 2 different chlorides formed. Alright, so guys, when you do your paper 5, go look at the notes that I have for you on the beginning of your practical paper. Read through that. Go through your first practical, go through your second practical. You can even do the third practical in your paper 5 booklet. Ask questions if you know, wherever you struggle. Please WhatsApp on the group or do it privately or whatever, and I'll get back to you if there's something that you're struggling with. Otherwise, good luck for the exam, and we'll see each other on the other side. Okay.